Okay, so I want to review a quick problem with you on doing multiple point charges. You should have already had this from last week, but let's go back over it. I understand several students are having some challenges. And you're going to do this same process with electric fields too, just using a different formula. So you'll need to be able to do this for both fields and forces. The process is very similar, the formula is just different. So let's look at this situation. We're given a 3-point charge system as shown here in the diagram, and it asks you to calculate the net force on Q1. That's this one right here. And it tells you that Q1 and Q2 are both the same, and Q3 is -4 microcoulombs. And again, remember, you are responsible to know your metric prefixes from giga all the way down to pico. So if you have not done that, go back to chapter 1 and get that going, because on a test when you see nano and pico and micro, which are the most commonly used prefixes in this unit, I'm not going to give you those on the test. You have to know them. All right, so let's take a look here and identify what we're given. Again, when we solve our problems, you want to use your 5-step problems. Whether you use given or whether you use G is up to you. All right, so I'm given that Q1 equals Q2, and they are 3 microcoulombs, so 3 times 10 to the -6 coulombs. You should be following along in your notes because you'll need this for the homework assignment. And I'm given that Q3 is -4 microcoulombs. 6 coulombs. All right. Also remember that when we deal with our force problems, we need K, and K, I'm just going to use 9 times 10 to the 9th to make it easier. You'll be given that constant for the test, so whether it's 8.99 or 9, it doesn't matter. You use whatever you're given. All right. They're asking me to find the net force, so F net on Q1. So I want to think about this for a second. Q2 is positive, Q1 is positive, Q3 is negative. So that means that Q2 will exert a force on Q1 that's repulsive. It'll be in this direction here. Oopsie. I'm running to the edge of my screen. I apologize. So it's going to go, I'm going to draw it up here. It's going to go this way, right? And so using a little bit of geometry here, if this is 23 degrees, then this angle is also 23 degrees, so that you know what you're doing. And then Q3 is going to exert an attractive force on Q1. So this is F3, 3 on 1, and this up here is F2 on 1, all right? So it helps to give us a, sort of an idea. I'm going to draw that over here again. Here's Q1. It's positive, right? And so here's my F2 on 1, and here's my F3 on 1. And some of you are going to want to jump to some conclusions about symmetry, but remember here the size of the charges are not the same, so you can't just assume that the x's cancel out. They won't, but they might. Sometimes you have to just sort of see on your system. So the next thing I need is my formula. Well, my formula is K Q1 Q2 over R squared, or Q naught over R squared, is equal to the force, right? And then you have some of the forces from Newton's second law. We don't need the mass times the acceleration in this one. We just add them. We add them in the x direction, we add them in the y direction, and then we find the net force. So let's just do our work here. So the first thing I want to do There's a couple of ways you can do this. I'm going to do it a little bit longer way just so it's a little bit easier. If you want to shorten it a little bit, you can. But the first thing I'm going to do is I'm going to find the force of 2 on 1, and that is going to be 9 times 10 to the 9th times 3 times 10 to the negative 6. And I'm going to square that. Make sure if you can multiply it twice or you can square it, but make sure that if you square it that you close those parentheses before you square it, otherwise you're just going to square the exponent on there. And then it's 1.3 meters, and I should have written that up here. R 2, 1 is 1.3 meters, and R 3, 1 is also 1.3 meters. We were also given that information. Don't forget our square here. Okay, so when I put that in my calculator, I'm going to get that F21 is 0.0479, and I'm going to carry it out a couple extra decimal places just to keep me honest here. All right, remember we don't want to round too early. F of 3 on 1 is going to be 9 times 10 to the 9th, and 3 times 10 to the negative 6th, and 4 times 10 to the negative 6, and that's all over 1.3 squared. Oops, squared. Okay. And when you plug that into our calculator, go ahead and do that, and you should get 0.0639. Again, I'm going to carry it out just a couple extra decimal places just to make sure. I carry the 4th or 5th is always the best, so you don't end up with a rounding error. We round at the 2nd place setting, so you want to get your rounding error beyond your 3rd decimal place for consistency. Okay, so now I have those. Now I can find my force in my x direction. Well, my force is in my x direction. This is the cosine of theta. Remember, this is cosine up here, right? And this is sine, will give me my y components. So my f of x is equal to F31 is positive. F31 is positive in x times the cosine of 23. And I'm going to subtract off because the x component of that force from 2 on 1 is actually negative. So F21 cosine 23. And I could write this all out. I'm not going to. I'm going to let you do that work on yourself. You should get positive 0.147. Again, I'm going to carry this on a little bit more because I've got another calculation to do with it. My f of y is both of them are negative, so it doesn't make any difference here if I reconcile it at the end or now. For just convenience sake, I'm going to do it here. So F21 sine 23 and F31 sine 23 will give me my y components. They're both negative, so whether I add them and then put on the negative sign or whether I put the negative sign in there, it doesn't matter. If you poke this into your calculator, you should get negative 0.0436. I'm going to carry it out again a few more decimal places. 9, these are in newtons. But what I've found are the x and y components. So I have an x component that's like this and a y component that's like this, but I need to find this force. I need to find this force and that angle, okay? So I'm going to clear this screen, maybe. going to clear the screen, and we're going to do it. So we had f of x was positive 0.147069 newtons, and we had Fy was equal to minus 0.04369666 newtons. Again, those numbers aren't our final answer. And we need to find F net. Well, remember we use the Pythagorean theorem, and F net equals the square root of f of x squared plus f of y squared. And you plug those into your calculator, and just to save some time because we have a shortened period today, you will get 0.1534 or 0.15 newtons. Okay, that's the magnitude, but don't forget I need the direction. Remember the direction, I find the inverse tan. So here's my f of x and here's my f of y, and I find the opposite over adjacent, so theta, my direction, is equal to the inverse tan of y over x. Alright, and so if you plug that in, then you should get 16.55 degrees south of east, or 343 degrees. So our final answer, the force is, net force on 1 is 0.15 newtons at 16.55 degrees south of east, or 0.15 newtons at 343.45 degrees. Again, we don't have to use all these decimals. Our convention is to use 2 decimal places, so I've just held through to that. Okay, if you have questions, email me.